Okay, so we have every number except what there? 0. So you can certainly do the 0 or negative infinity to 0 and 0 to infinity, but there might be an easier, faster way to do it. Mathematicians are incredibly lazy when it comes to writing stuff. Okay, if we take all numbers, does anybody remember what we call that? All reals. So check it out. If we want this domain the easiest way, and your answers are okay, negative infinity to 0, union 0 to infinity, we can also say, hey, it's the set of all x such that x doesn't equal what? Does that cover every other number? Yeah, that's every number. We can write that answer this way. If you'd rather, we can write this using your intervals. So I'll do interval as well. X is in the interval, and Chelsea, I'm going to pick on you for a second. What's different about mine and yours? What did you use? So you used a bracket, I used a parenthesis. Which one of these means that we touch it? The bracket means we touch it. Is there any point here where we get to use x equals 0? Or does it not exist there? So we're going to use parentheses there. Union, same thing. We're going to start at 0, but we don't touch it, and we go all the way out to infinity. Those are equal answers. They mean the exact same thing. Every x that's not 0 is the same as saying everything from negative infinity to 0, not including 0, and then 0 to infinity. Okay, the range. What's the lowest value your function ever hits? The lowest y value of our function, since we're looking at the y's. I think it hits lower than 0. So depending, I didn't make the comment with you guys. If you view this, and I can't find my cursor, I have trouble seeing it. Do you guys think this levels out, or do you think it's going to keep going downward? Okay, if I'm going to turn it so it keeps going downward, just so that's a little bit more clear. Okay, in this situation, if we look at horizontal lines, will it hit this horizontal line? Right, ugh, that one. Okay, how low can it go? Forever, which is to negative infinity. Okay, so we're at negative infinity, and we're just going to do the range here, and we'll start, once I find it, there it is. Y is in the interval. We start at negative infinity. How high up can we keep going until we don't ever touch the function? Well, let's check. You say 3, right? Will I hit it right here? Would that still cross? If I keep going up, will it hit here still? How about here? Now here it gets weird, but do I hit it at least once? I don't hit it here, but I hit it over here. Well, I keep hitting it. How far? So we could say negative infinity to infinity, but there's an easier way. There's our first one, negative infinity to infinity. I'm cool with that. Or if we just wanted to word this, y is in the set of, what do we call all the numbers? There's a symbol for it, all reals. Did we learn the symbol yesterday? Blackboard R. This means all real numbers. So you can use this. If we didn't see it yesterday, now we have. That is how I write all real numbers. It's not just me, that's every mathematician. Okay, positive. We're just going to have you guys go to both boards, and we don't need to write them right now because we're going to get a lot of practice writing it in our homework, unless you want to write them right now. What does positive mean? If a function is positive, that means it lives where? Up. Above what? Okay, where is this graph above the x-axis? If we start all the way on the left side of the graph, is it already above the x-axis here? So from negative infinity up until what value does it stop being a positive? So let's write that interval first. We have negative infinity to negative 3. Now, at negative 3, is it really positive, or is it at 0, which we wouldn't say is positive? It's not positive, which means bracket or parenthesis. Notice the lack of affirmation. If we don't touch it, what do we use? Parentheses. Okay, where else? Now we'll tie this together. We'll unite it with something. Am I positive again once I leave that 0? I can't find my cursor ever on the screen. Okay, so I'm positive again. So it looks like from negative 3 to where does it stop being able to say it's positive? So you're looking at the y value, right? I like it. At that y value, it doesn't exist. What x value are we at, though? 0. We can't say it's positive if it doesn't exist. Do you agree? So there we went from negative 3 to where? 0. Oh my gosh, this cursor is going to be the death of me. I can never find it. Negative 3 to 0. Is there anywhere else it's positive? Where else is it positive? We're just going to keep continuing on along this. 0 to 3. Love it. So you can't, because those parentheses mean as close as you can get to 0 from this side. So like we're getting on that first one, -3 to 0. The last numbers that we get, we never stop getting closer, because pick something close to 0, a little negative, like 0.1. Can you get closer to 0 than 0.1? 0.01, right? -0.01. Could I get closer than that again? Now, would we ever stop listing those numbers? So the only way that we can show that we never actually touch it is by doing this. Like we have to leave the gaps when x value is not satisfied every time. Anywhere else that is positive. We covered all these sections. Is everywhere, oh my gosh, is everywhere that we have scribbled above the x-axis? Okay, so that's all of our positives. Is there anywhere where the graph is underneath the x-axis? From which x value to where? From 3 to infinity. Now, Chelsea, I heard you say -infinity, and I know 100% why. Remember, okay, my bad, I misheard. That's on me. Where's the only place that we're ever going to look at the y's? The y values. There's only one of these questions that we look at the y's. The range. Only the range. Everything else is just the x values that we're after. Okay, everywhere from 3 out to positive infinity, this thing is below the curve over here. Okay, increasing means going upward or downward? Okay, do you see any places on this graph where it's going upward? Starting at what x value? Okay, so if we start at -3, it goes upward until it hits what x value? Yeah, I agree. It's 0. Because everything is the x values except for the range. Everywhere along this section, and oh my gosh, I'm going to have to switch to the other program. From here to here, I think I'm increasing. It's going upward as I go left to right. Is there anywhere else that it does that? Nope, so that's it. That's our only increasing, which means everywhere else it's probably doing what? But let's convince ourselves of that. If we're looking at the decreasing intervals, is it decreasing everywhere over here? Oh, no, I don't. What the heck? Can you guys see the cursor? It is so hard for me to find. Is it decreasing right now? All the way from -infinity to where? Okay, so it looks like -infinity to -3. And then we'll unite this with, where's the next place it becomes negative? 0 to 3. It looks like it's going downward on this section also. Now, this one, Adeline, I'm going to piggyback off your comment. Are we still going downward after that? So did we really have to stop at 3 here? No, because it's a closed point and we don't have to do any weird like jumps anywhere. Why won't you undo? There it is. How far to the right can we go where we're still going downward? So are you saying the first two, as in, can you go up and point to it, just because I don't quite understand? I'm sorry. This one. Can we just go -infinity until 30? Because go ahead and put your finger at the -infinity part of the graph, like where it starts. And then, yep, there. Now show me where it's going downward and stop when it stops going down. Like once you go to that next part, it starts going up, right? So we can't say that it's decreasing that whole thing because it only decreases until x equals -3. For the positive, is 0 a positive number? So that's why we take that gap there too, because we're saying when is it positive? If it's at 0, it's not positive, right? Because where isn't it positive in there? What's the one place where it's not positive? It's also not negative as far as the value. What's it at -3? What's the value of your function? Are you sure? At x equals -3, put your finger there. You're good. What's the value of your function? What's the y value it spits out? Would you say that's positive? Yep, cool. Awesome. I'm so glad that you kept asking. Always do that. Cool. How about the intercepts? So if you say -3, you're missing a whole number in it. -3 what? -3, 0? Any others? 3, 0? What kind of intercepts did we just identify? These are the x's. What about the y-intercept? Is there one? Ooh, I got somebody. Somebody said 3. What's up with that point at 0, 3, though? Is it actually there? No. Does it ever touch the y-axis? There's no y-intercept on this graph. It has that hole in it. It never gets satisfied. So if it's a closed hole, it's... So let's switch that, Rodelia. Just, I know where your head's going. I'm pretty sure. I'm going to make you guys repeat something. If it's open, don't use it. Okay, one more time, we'll try that. If it's open, don't use it. Okay, that implies that anything that's not open does get used, right? Okay, only place you'll ever ignore a value is if it's an open point like that, which we will get to. Okay, these things is going to be what your homework is like, just so you guys are aware. Who does not have their computer back yet, or a computer yet? Okay, do you have a permission slip that you're going to get signed? You didn't get a permission slip? Okay, so that's what I would call the permission slip, but that's fine. Did you take it home? Okay, tonight you're going to do what with it? And okay, so you're going to get yours. Okay, we need computers by Friday. That's the goal. Got to have your computer by Friday. Okay, for this, we have one more little tiny thing to look at, and then we're going to have a bunch of time for homework today. When we have time in class for homework, if you finish it in class, and this is not a threat, I know it sounds like it, if everybody finishes early, we can get a head start tomorrow. And if we get a head start, it means tomorrow in class we would have time to do what? Homework. Not free time. I don't believe in free time. I don't know if that's true necessarily. But all right, we have like a couple little things. Questions about the bell ringer before we keep kicking forward. It takes a little bit of practice. The notation stuff, I'm going to be like chill with you, but please do notice how gross this would be if we didn't use that little E that says in the setup. Everything looks like ordered pairs if we don't use this lovely symbol right here, that epsilon. Everything else looks like an ordered pair. It looks like the euro symbol, if you know what the money euro symbol looks like. Okay, we have one last thing to add to our notes, and then we'll do some homework time. Quick question. What's slope? Whoa, I heard all sorts of stuff. K over, what was yours? So you're thinking of, interesting, direct variation, which is an awesome idea to have in your head. You're not wildly far off. Love that. Did you guys hear Raylene? Rise over run. Oh, shoot. Okay, give me, that's like the first time you ever see it. It's rise over run. Give me another way to think about slope. Love it. Yours louder. Delta y over delta x. I liked your answer too. Yours was less specific. What is the slope in your equation y equals mx plus b?
No, the M.
M, my guy. Cool. All right. So awesome. We have one last little thing. I want you guys back at your desks. We're going to add one last piece into our notes, and then we are going to have some time to work on stuff where I'm here to answer your questions. Okay. Last little part of section 1.1. Did I give you guys homework yesterday? No. Okay. All right. So last little thing that we're going to talk about. You will see me write this exactly one time, word for word, and then we have a shorthand for this. The last little piece that we're going to talk about today is a vocab, and we're going to call this the average rate of change. Okay, you will never see me write this again because we're going to use a shorthand moving forward, and it's a shorthand that we'll see in Algebra 2, we'll see it in pre-calc, in calculus if you take it. Henceforth, AROC, A-R-O-C. Okay. We are looking at the average rate of change. Paula, you don't have to write it all down, but make sure you look like you're writing something so when we get to doing the mathy part. Okay. How many of you guys remember talking about rates of change in Algebra 1? So, a few of you guys. Rates of change is pretty much a synonym or the same meaning as what other word that we've already discussed in here? Slope. Awesome. When we think about the difference between a rate of change and a slope, depends honestly on the textbook that you're dealing with. If it's pure mathy stuff, we tend to call it the slope. But if it's a rate of change with units like gallons per minute, miles per hour, when we add those units, it changes to a rate of change. Mathematically, they're the same. This is really just going to be the slope between 2 points. The slope, rather, between 2 points. Now, when you encounter the average rate of change in our problems, they're going to present them kind of ugly. We're going to do one with it. It has all the information that we need. They just like to give it and make sure that we really understand stuff. So what we're going to do first is if we're looking for the average rate of change, we're going to make sure that we all have what we said out loud. How do you find this? I'm going to go with Raylene's first. It's rise over run. Okay, there's the first one. Now, I also liked Adeline's here. She said delta y over delta x. Okay, you guys all remember seeing that. I'm fairly sure of it. How do you calculate delta y? The change in y. So how many points do you think we need? 2, and we've already written that. So we'll do a concrete example, but let's say we had x1, y1, and x2, y2. If I do y2 minus y1 in the numerator, the top, is that okay? What has to go in the bottom the second I commit to doing that? Is that the only way we can do this? Okay, up to you if you want to write this, and really it's up to you if you want to write everything with the exception if you got to look like you're doing something. What if I was feeling a little crazy and I went this way? y1 minus y2. Is it allowed? As long as what is in the denominator? Good. Your order has to stay consistent once you start writing it. It can change in between them. Always stay consistent. Now, we're going to do one problem with an average rate of change, and we're going to do this from a graph. And you don't have to draw the whole graph. You can. If anybody wants to draw a graph and you don't want to have to take the time to make your nice coordinate plane, would you guys use these? These are sticky notes. I'm sorry, Adeline. Not sorry that I hit you. I'm sorry that I startled you. I don't think that hurt. I hope it didn't hurt. Okay, well, I take it back then. I'm not sorry. I lied. I'm a sorry here. All right, check it out. We're going to make a little graph here, and it's not going to be perfect. And I'm still learning to do this, but it has this thing that I can use, which I don't think I love, but we're going to try it. Okay, so check it out. I have a lovely coordinate plane, and I don't need any more than that. I will go ahead and put the tick marks on here just so you guys can see them. And this is an example, and I probably should have specified. And let's just get a few nice points. So 1, 2, 3, 1, 2, 3. I drew way bigger scale than I needed, but that's okay. Okay, anybody want to try drawing on this tablet to draw our graph? Okay. A protractor?
Yes.
Absolutely I do. They're always going to be up in this basket right by this desk.
Okay.
But you can keep that. And you don't even have to come up here. You can go over there.
Oh.
Okay, so Savia's going to draw us a nice graph here. And all I need you to do, Savia, is somewhere I need to be able to identify 2 nice points on this graph. See? Welcome to my world. I just scribble on the screen until I see it. Are you scribbling? Oh, you're up there. Okay, so she's going to draw us a nice graph here. And I like to do this. I'm going to pause this until she's done. I like to do this because, oh, hold on. Will you stop for 1 second? Will you lift your pen? Just so I can pause it. But I don't think I'm going to get to use that. What I want us to do, and the way that these problems are going to present themselves, is we're going to find on this the average rate of change on an interval they give us. And let's just say we have it like this. On the interval, -2, 2. Now, notice immediately that I did not use parentheses. The fact that these are brackets written on that -2, 2 tell us that those points are included or not included. Try again. Bracket includes the points. Yep, it doesn't necessarily stop there. We can think about this interval. The interval that I've highlighted is just this little part of the graph. All that in there is all that I've highlighted. Okay, so it does exist on that little piece. Now, what we're going to ask for on this average rate of change on this interval is we just need to be able to identify these points and find the slope between them. If we want to write them as x1, y1, and x2, y2, we certainly can, but it is not required. What's one of those points? Either of the points that we're going to find the slope between. -2, 0. And like you guys will be given the graph on your homework. This is my and symbol. That is not a plus, just so y'all know. And what's the other point? 2, 2. Now, could we draw a line right through both of them? Like, is there a single line that connects those points? And it is not going to be perfect here, but we're going to try. It's about that one. When we ask for the average rate of change, all I'm asking for is what's the slope of this line? If you have these 2 points, can we find the slope? Prove it.
Sorry for the interruption, but
It's okay.
all seniors need to come to the office for their eye vision test. All seniors, please.
So I was just telling us we're going to find the average rate of change on this interval. I could have picked any numbers here. Yep, this is just part of the given problem. Good question. All we're looking for the average rate of change on this interval is the slope of that line, which we haven't done one. Do we need to do one together? Okay. If you want to ignore me as I'm helping, is that okay if you don't need the help? For sure. Should you ignore me if it's like not just a helping people through a problem? I mean, hope not. At least look like you're not ignoring me, conceivably. Okay, well, let's look. I'm feeling silly because I don't remember how to find slope. Oofda. How on earth do I find slope? What do you want to do? What minus what? Okay, so you've given me the x's. What goes on top, though?
Oh, the y's.
2. So we have to make a decision. Do you want 2 minus 0, or do you want 0 minus 2? Okay, 2 minus 0 in the numerator. Over what has to go in the denominator then? So, no, I like your answer. I was sewing somebody else, but check this out. We did this minus this, right? That means we better do it in the same order. We better do 2 minus negative 2. Okay, what happens when I subtract a negative? Big add. Okay, so I'm going to make, I say plus a positive, but you're good. Okay, what's in the numerator? 2 over, what's in the denominator? 4. Does that simplify? 1/2. What's the average rate of change on the interval from negative 2 to 2? We're done. That's it. Yep, that is the one that you guys couldn't do yesterday because we hadn't discussed it. Okay, now this gets used all the time. Have we talked about average rate of change at all? Like the first day, did I share a kind of mind-blowing fact with you? Okay, if I did, I'm sorry because this is going to be a repeat, but I think this is really interesting and kind of mind-blowing the first time you think about it. Okay, how often would you say in your day you're not moving at all? Like obviously in your desks, you're not really moving a whole lot, but is there many times during the day that you're not moving? Like even if you're sitting there watching TV, you don't like pretty regularly probably get up to go pee or go get something to eat or go do something. Like very seldomly that we don't move a whole lot, right? I'm going to make a claim. I think that on average, you guys' average speed, if you want that rate of change, is 0. Would you agree with that? Why? So we did talk about this seemingly. From the time we wake up to the time we move, if you only looked at those 2, we haven't moved at all. Your average rate of change is 0, which that always bugs me because I know I move a lot faster than 0. Okay, good news. That's all I got for now. Better news, I have some homework for you. Best news, I'm here to help with the homework. So, on the homework, just because some of you guys haven't had before, when you write this, here's what I want on the top of your page. If this is a page of paper that you're about to do your homework on, this is me. Don't write my name. You write your name. On the top left, please write your name. So here I am. And I don't care if there's nobody else with that name. You can use that. If you have a nickname that I don't know, please tell me. We're going to put your name. And then below this is 4th hour, Algebra 2. Okay, last one that you need, and you will find this on the Google Classroom, and I'll show you guys where we're going to find that, is the following. We have homework 1.1. Now, right off the bat, this just means topic 1 or chapter 1, section 1. If I get the page wrong or if I forget the page, you can just find it at the end of the first chapter, first section. Rodelia, can you tell me the page number?
Page 10.
Page 10. And can you tell me the problems that we have?
4 to 12, 18 to 27.
4 to 12 and 18 to 27. Okay, this never has to get written. You'll see it on the Google Classroom. Every assignment of mine, if I give it to you today, it is due tomorrow. Okay, I'll fix it up there. It's weird. I don't know why. I got classes mixed up somewhere. My guess is that was pre-calc. Okay, so last little thing. For those of you that haven't had my class, who in here has been up at like 2 a.m. or late night, like crying on your bed because you don't understand the math that you're trying to do for your homework that's due tomorrow? I've done it, like for sure. If you've never had to cry about math, we're gonna get you this year. All right, that's a joke. Not a very good one, apparently. But okay, here's the rule. Outside of my class, you guys are what? Sophomores or juniors? Mix of both. Okay, so we're gonna say outside of my class, 40 minutes. If you're working on the homework for 40 minutes and you've only gotten to number 7, stop. Don't spend more time. Don't copy it. Like homework's worth such little amount that if you copy it, you'll probably get away with it. I just want to tell you that. But it's not in your best interest. If you don't learn how to do it here, you're not going to be able to do it on the test. That's 50% of your grade. Okay, I'm way more lenient on the homework stuff. Try to do it, 40 minutes, stop. If it's taking you more than 40 minutes outside of class, it says that there's a misunderstanding. Either I taught it poorly or you missed something. Whatever the cause is, doesn't matter. Just come talk to me. I'm happy to give an extension as long as you come in and get help so we understand how to do it. 40 minutes, never be crying. Yo.
Is our question day like?
Our question day.
We don't have a did we take out our question day? So, oh my days. Homework is tomorrow. Due tomorrow.
Yes, we did that last year too, though, didn't we?
No.
I don't think we had a gap in between days, did we?
We did have a gap. Didn't.
I don't think we did last year. I might have at the very beginning and then decided I hated it. Russell did that, where it was homework on Monday, you handed in Wednesday. That was a Russell thing. I did it one year and I hated it.
Wait, actually? No, you got last year you gave us 2 days to do it.
Did I really?
Yeah, I think so.
Okay, well.
Because if we did it and then somehow we didn't understand, we did it, we didn't go over them, and then you say, okay, bring it back on.
Okay, well, I might have done that last year, but I'll tell you, I hated it if I didn't say that. I want it tomorrow. If we have questions, we can spend some time at the start of class because I think what wound up happening, not for you guys, of course, was that if it's not due till Wednesday or 2 days from now, then somebody would never start it and not really use that as what it's for. Practice tonight. Cool. All right, but you guys have roughly 20 minutes to work on this right now. If you're at home and you're going, oh man, I forgot my notebook. I don't know where it is. Here's the Google Classroom. We're going to do a little, I'm going to pause this.